Next page. Let's do a chemistry experiment right here on your microscope. So normally I'm not a big fan of making messes on it. I'm still not, but you might drop a couple of things, make some mess. So here's how we're going to do it. You're going to make your first slide. You're not going to make it out of glass. Be creative. Open your mind. There's so many more things you can use besides just a piece of glass to do a microscope slide. For instance, I heard one time someone say they use business cards as microscope slides. Not their own. When somebody gave them a business card, they would turn it into a microscope slide like this. So, flip over. I hope we can flip over. Yeah. Boop. All right, so a business card's about that big. We can use this side. What we're going to do is we're going to poke a hole right there, straight through. Try not to bend it like I did. And go down just a little bit. Poke a hole all the way through. Come back a little bit. Poke a hole through. Now you're going to take your tape. Oh, so you can get that, find that sticky spot, or sticky, the edge spot. I feel it. Perfect. Got it. It's difficult to get off. There it goes. Okay. I'm going to take this tape. There are two sides, remember, to the card. There's a side you poked in that's kind of smooth, and there's a rough side. I'm going to go on the smooth side. Make sure it's long enough. And cover all my holes. Smooth. 3 holes, completely covered, seal around them. I have a toothpick here, so I'm just going to use that to pop the tape off. Pop. All right. So I have these 3 holes. Let's reopen them. Toothpick. Should have probably bent them back a little bit before I put the tape on, because my finger went under and kind of bent them where I didn't want them to go. All right. Not perfect, but I'm going to make sure it's open like that, like that, like that, like this. And I'm going to take those rings. And the rings, when you make a slide, they're really there to catch things that spill over. So we call it a well slide, because the ring will go around that hole, support it. Sorry, just putting it like that. I have one well. I'm saving these little dots too. There's a reason. Dot. Oops, there's another dot. And I'm also stacking them for a reason. But it's my next ring. One more. Okay. And that. Okay, so now I have 3 wells. Let's find out what our topic is. So this is really building into doing things on your own, coming up with your own experiment. Crystal chemistry analysis. So chemistry, it's the study of matters, properties, how it reacts with other chemicals in the environment. Crystals are made of molecules or atoms that stack neatly into building blocks and form special shapes with special properties. Cool. The science behind it, if I have a solution, so let's say salt water, and I dehydrate it, the water goes away and all the solids will stick together. And if they bind, they form a crystal. Crystallization is what happens when you take the water out and things stick together and form this new solid. There are two compounds. One's called an ionic. Ionic, I always think of ions, like all these charges. Writing in my book and not doing the best job making it, but there are some pluses there. There's that. It's kind of blocky. So right in the beginning, I can see there's a plus sign on top of a plus sign. So anything that has a bold, like Na, when you see your chemistry class, a Cl minus, right? Mg plus, magnesium. Those all have a charge on them. If they're left alone with each other and you take water away, they stick together like blocks. Ions do. The other that you're going to look at is called polar covalent. Polar covalent, they have poles like the South Pole and North Pole, so they have a little bit of a wobble to them. They'll stick together if they're pushed together, but they don't care about getting together. Once they're together, they don't care about getting apart. It's just like you know, your buddies from high school just sit around playing Mario Kart on TV. I don't want to go over to Joe's house. We do nothing but sit and play Mario Kart. Goes to Joe's house, what's he do? He sits and play Mario Kart all day. You can't get him away. So these polar covalents, sometimes they're hard to stick together. But once they're stuck together, they're also hard to get apart. A little different. If I introduce water to these, if I put water on top of an ionic compound, it splits in different directions. If you put water on a polar, it takes its time. It's like, this bath is kind of nice. I'm going to hang out for a while. So these polars, they're not really active. When they stack, they don't make nice, perfect crystals. They make kind of like these odd shaped things all over the place. So there's some traits to these two compounds. Like I said, this one has a charge. It loves water. Put a big heart there for water. H2O. Right? It likes to build perfect shapes. So we'll say squared off shapes. Polar, whatever, doesn't care. It's kind of iffy about the water, kind of iffy about the shapes. So here's what happens. You were in the kitchen doing some cooking and you made a mistake. And let me tell you about a mistake somebody made when I was in the cooking class a couple of years ago. It was on St. Patrick's Day and we were making soda bread and Reubens and all kinds of good stuff. And the person that was in charge of doing soda bread went over to the counter and there was a big bucket of white crystalline stuff right next to another big bucket of white crystalline stuff. And she took a scoop, a 1 cup scoop, and put it into her soda bread, cooked it. Everyone gathered around the table and almost like everybody at one time pulled the soda bread right back out of their mouth. She had taken a scoop of salt and put it in instead of a scoop of sugar. And so it was like, ugh, terrible, terrible, terrible. But have you ever looked at salt and sugar? Grab your envelope. You actually have sugar in there. The white packet, not the blues, the sweeteners, and stuff like that. So you have a sugar packet. You also have a salt packet and a pepper. Maybe we'll pull the salt and pepper out together. Go together like salt and pepper. So you have sugar, salt, pepper. Pepper is just the funsy one. So we're going to see what happens with salt. We're going to take a look at it underneath the microscope. Just tear the edge off of this packet. Open it up. And I just want a couple crystals in. I don't want to make a big mound of salt. So I'm just going to put a couple crystals in. I mean, technically I could dump it out on another piece of paper and just, yeah, it's plenty. And just, you know, use my spatula or my tweezers to move it. Just my salt. So I want to mark it. Oops, I bumped. So I remember. Sugar. Put it all the way on the opposite side so I don't mix it up. Just a couple. Oops, I just made a pile. So you really only need enough to cover the bottom. I guess I didn't put as much as I thought. Ah, now I did. I think I got enough sugar on that one. What do you think? Wow. All right. Well, let's tap it off. Cappy. I may not be able to get rid of all that sugar. Springboard, bong, bong, bong. All right, well, I managed to get a thin layer of sugar, but I also got rid of most of my salt. So now I'm just gonna do the same mistake over here. Nice, nice. I tap it around. I've got some salt in there, I've got some sugar in there, and put some pepper right in the middle. It's a party. The pepper doesn't want to come out. There you go. Got some pepper on there. Salt, sugar, pepper. All right. We're going to see if we can figure out what's ionic in here, what's polar covalent, or if there's any of either of them in here. So let's start with sugar. It's my blue ring. My stage is down. Sliding in there. I want to get a good look at this on the switch camera. Right, there's my blue ring. May as well focus on it. I know it's going to be, yeah, look at that. Whoa, it's covered. I went crazy, remember? Sugar stuck all over everything. Let's go in a little bit closer. Huh. There's the edge of the ripped paper. That's kind of cool. Look at all those little sugar crystals. Oh yeah. Really shattered it. So if I look at a couple of these sugar crystals, I don't know if I can really describe perfectly. They're kind of like boulders, I guess. So I'm going to draw it. Not really all that square. So I'm going to do first my sugar. Has kind of a rounded corner. Comes up or this way. And I don't know if you can tell. I can't tilt it, but it's not square. It's actually a long structure. It goes deep into the scene. So right now it's poking way up, but it has another one sitting next to it. Same idea. It's more oval. One below it. And then there's also a one over here. And then we got to put my paper in. Love the paper. So they're not, I don't know how to describe them. They're not really, they don't remind me of crystals other than the fact that they look cold and kind of icy. So let's take a peek at the salt. Right, there's my ring. I can go ahead and edge. So we know there's a ring. Whoa, there they are. How would I describe that? Doesn't look like anything. Oh yeah, there you go. They look exactly like cubes. Lots of them. It's like somebody's been playing dice. I've got plenty of cubes. Do you think that would be polar or ionic? Some weird round over here. I bet my sugar got in the salt. I would probably go with the ionic. So I have all these crystals that look like dice everywhere. So if I spill again, or I was curious about which container was the sugar, I could definitely tell which one was the salt, right? And then what magnification? We're at the 4 on the red, the objective, and then 10 at the ocular. So 40 times on salt crystals, 40 times sugar crystals. Oops, forgot to look at the pepper. Pepper just looks like an old moldy piece of bread. It might actually be moldy. Gross. I could have eaten that pepper and not even known. You know how many nasty things you eat at restaurants, or even the people in your house have cooked you and they didn't know it was bad? Gross. Yeah, so there are a couple black broken up pieces of pepper. Looks like some white pepper in there too. So we think we've got it figured out. We think that salt is one thing and the sugar is another. So let's do the second part of that experiment. And we know that one really loves water and one's like, meh, water smarter. It's everywhere. Let's start with this one. What was that? Was that sugar or salt? That was the salt. Looked like dice. It might be, I don't know, a couple of those may be sugar. But we're going to get a little water. Eyedropper, push the air out. Not all of it, just a little bit. Suck up a couple of drops of water. You don't need much. We're going to see what happens when we carry out this chemistry reaction. So I've got a dropper. Oh, I guess I can do this. I'm going to just hang one drop of water. Squeeze the dropper just a little bit so one drop just kind of dangles there. And then let it drop right in the middle. Do you see anything? You can actually see the salt breaking down right in front of your eyes. Pretty sweet. It's almost like I'm seeing ghosts in the image. See the little guy over here that looks like a skeleton? Yeah, it looks like Creepy's going behind. Love it. Microscope chemistry. Who'd thunk? I like the one in the top left. It's just splitting. It's like a big chunk of ice and it's melting. I have a pretty decent bubble of water. Okay, let's do the same thing over here with the sugar. Oops. Goodness. There you go. Oh yeah, that's the one. I want to see it go. Okay, same idea. We're going to water drop would do. I have a little bit of water, still left in this. I only need to dangle a drop. Oh, where'd my rock go? And this one's going not so bad. Whoops. I blew it and moved. Sheesh. Sure seems like suspended animation. Huh. Looks like it's done reacting already. So which one seemed like it went faster? You could time it. It could be part of your experiment. I would guess the salt went a little bit faster. Which one would you say was the perfectly stackable, the cube shape? I would guess the salt again. So which one of these two, a polar or the ionic, likes to dissolve things quickly and also likes to make perfect shapes? I don't want to say cube necessarily, but perfect shapes. It's the salt. So that's kind of the first experiment. What's going to happen? Is there a way that I can tell salt from sugar? What can I do with water? What can I do looking under the microscope to figure out what these things are? Pepper clearly didn't fall in either of those categories.